The general conviction among most researchers is that the speculation of how things came to be stays the essential clarification for the early times of the universe. This hypothesis joins the progress of stars, planets, and so forth, life on those planets, including ourselves, not enduring. It's a genuinely odd theory, named the Big Bang. It offers an enlightening appraisal concerning what might have happened at first. The universe was thick, in a short space, more unpretentious than a pinhead, with particles thickly dazzled. From this moment, a giant effect of matter and energy happened, known as the Big Bang. This event, happening billions of years ago, set up the fanning out of galactic history. However, advancements in genuine information have set off growing abnormalities with the presumptions of this speculation. When NASA launched the James Webb Space Telescope, the biggest and most advanced space science observatory of all time, experts theorized that its observations would confirm the speculation of the universe's origin. Sadly, after only a year in space, the telescope flabbergasted experts with its ability to peer so deeply into the universe's past. The James Webb Telescope's shocking limits have revealed countless systems going as far back to a time so old that it challenges our understanding of the universe's origins. This discovery has ignited an intense investigation into what existed before the Big Bang. One key moment in this mission occurred when cosmologist Rohan Natu, working with data from the telescope, unexpectedly found a galaxy from just a brief time after the Big Bang, making it the most distant galaxy ever observed. Natu's discovery sent shockwaves through established researchers, highlighting the amazing capabilities of the James Webb Telescope. Its crucial goal to change our view of the universe has only just begun, promising to uncover astonishing insights into the earliest stages of the universe's existence. This period, scarcely examined previously, holds the key to understanding the progress of the first stars and structures. The telescope's discoveries have gone against initial theory, revealing systems with characteristics outperforming past expectations. This wonderful surge of early systems has sparked a storm of scientific inquiry, testing experts to accommodate these findings with existing theories. As researchers wrestle with these discoveries, they face fundamental questions about the very nature of the universe and the forces shaping its development. Beyond the James Webb Telescope's advancements, which are consistent, it is located 1.5 million kilometers away from Earth, protected from normal interference, and cooled to near absolute zero by its tennis court-sized sunshield. The telescope features a huge, segmented mirror and incredibly sensitive instruments designed to reveal details of the early universe, previously hidden. This period, known as the Big Dawn, occurred around a couple of 100 million years after the Big Bang, marking the time when the first stars and galaxies began to form. The process by which this unfolded remains a subject of intense research, with hypotheses ranging from the effects of dark matter and dark energy to the interactions between star-forming gas and dust. The telescope's view of galaxies from the cosmic dawn presents a unique opportunity for cosmologists to test how they could interpret these complex dynamics. By investigating these ancient systems, researchers can either confirm the validity of their current models or reveal gaps in understanding that could lead to pivotal new discoveries. Initially, the telescope was expected to observe only a few faint and small galaxies in its pilot studies. However, reality has far outperformed these expectations. The telescope's early images of the distant universe revealed an abundance of galaxies with ages, sizes, and brightness levels that defied all predictions. This astounding overflow of early galaxies has triggered a race among space experts to set new records for the earliest known galaxies, with new discoveries emerging every day, leaving the scientific community in awe. Following the James Webb Telescope's discoveries, specialists and observers have rushed to study the presence of these surprisingly advanced early galaxies. Some speculate that errors in the telescope's interpretation of huge observations could be responsible for these unexpected findings. That said, the consensus remains that these discoveries represent a paradigm shift in how we might interpret the early universe and provide thrilling glimpses into the potential for cosmic evolution. The new discoveries from the James Webb Space Telescope regarding galaxies have raised fundamental questions about the nature of the universe and tested the assumptions of standard cosmological models. While certain scientists are investigating whether these observations can be reconciled with existing theories, others suggest that they may be the first signs that the universe is far more complex and baffling than previously imagined. The question at stake is our fundamental understanding of how the universe we know arose out of primordial chaos. The early revelations of the JWST could reshape our essential ideas of cosmic history, uncovering insights not only on distant galaxies and ancient structures, but also on the very nature of our own Milky Way. As Mark McFan, senior scientist for science and research at the European Space Organization, puts it, "You build these machines not to confirm theory, but to break it. You simply have no idea how it's going to break." The origins of the JWST can be traced back to the Space Telescope Science Institute, STSCI, in 1985, even before the Hubble Space Telescope was launched. At the time, G. Weir, then head of STSCI, was tasked with imagining what might come after Hubble. Despite initial doubts, Weir and a small group began laying the groundwork for what would ultimately become the James Webb Space Telescope. Unlike Hubble, which primarily captures visible light, the JWST was designed to observe in the infrared spectrum, allowing it to peer much deeper into the universe. This capability is crucial for studying distant galaxies whose light has been stretched into the infrared due to the expansion of the universe, making them invisible to telescopes like Hubble. With its enormous, cold, star-like mirror, the JWST became the premier tool for unlocking the secrets of cosmic dawn. The need for the JWST was highlighted in 1995 when the Hubble Deep Field Observation uncovered a vast number of galaxies in what was believed to be an empty patch of sky. This revelation demonstrated the richness of the early universe and underscored the need for a telescope capable of probing much deeper into cosmic history. After 20 long years of development and a cost of around $1 billion, the JWST was finally launched on December 25, 2021. By July 2022, it was ready to begin its most critical year of scientific observations. Early initiatives like the Early Release Science Program and the General Observer Program were specifically designed to search for early galaxies. While initial expectations were modest, the results far surpassed them. JWST observations have challenged existing models of the early universe, revealing galaxies that defy conventional cosmological assumptions. These remarkable discoveries emphasize the importance of pushing the boundaries of scientific inquiry and highlight the exceptional capabilities of cutting-edge technologies like the James Webb Space Telescope. As researchers continue to analyze JWST data, they may uncover further insights that test and expand our understanding of the universe. When the first data began rolling in from the JWST, cosmologists were eagerly anticipating the results. Many had been preparing their data analysis pipelines for this moment for years. Instead of following the traditional peer review process, which typically takes months, researchers decided to share their discoveries on preprint servers like AR14, a platform for research papers that have not yet been reviewed by experts. This approach allowed for a new type of peer review to take place via social media platforms like Twitter, where the scientific community could quickly discuss findings. Rohan Natu described this process as science by press release, and the ensuing storm of discussion was both intense and remarkable. However, there were concerns about the potential downsides of this rapid dissemination of results. Klaus Pontypool, a JWST project scientist at STSCI, cautioned that while the fast sharing of results facilitates rapid dissemination and discussion, there is also a risk of overwhelming the process. The general agreement among most researchers is that the speculation of how things came to be remains the essential explanation for the early times of the universe. This hypothesis incorporates the movement of stars, planets, and life on those planets, including ourselves. Despite its unusual name, the Big Bang offers a significant explanation for what could have happened at the universe's origins. The universe was thick, packed into a space smaller than a pinhead, filled with densely packed particles. From this moment, a massive effect of matter and energy occurred, known as the Big Bang. This event, happening billions of years ago, set up for the unfolding of past galactic history. However, changes in scientific information have led to growing disparities with the assumptions underlying this theory. When NASA launched the James Webb Space Telescope, the largest and most advanced space science observatory ever built, researchers speculated that its observations would support the theory of the universe's origin. Unfortunately, after just 1 year in space, the telescope shocked scientists with its ability to peer deeply into the universe's past. The James Webb Space Telescope's remarkable abilities have revealed galaxies dating back to such ancient times that they challenge our understanding of the universe's origins. This discovery has sparked serious investigation into what existed before the Big Bang.